Hi guys, my name is Aidan Tan, and for my video project in Period 2 and 1, I am doing related rates. The goal of related rates. Related rate problems allow us to compute the rate of change of one quantity in terms of change of another quantity. You have to find an equation that relates the two quantities and use the rules you have learned to find the derivative of both sides with respect to time. Practice problem number 1. An oil spill is creating a circle that has a radius that is increasing by 10 feet per minute. As a result, the area is also increasing. What is the rate of the area increasing by when the radius is 60 feet? So every related rate problem has 4 main steps. Step 1. Read and identify rates and variables. In our problem, the rate of the area is represented by dA over dt. It shows the rate of the area with respect to time. The rate as the radius is increasing with respect to time is shown by dr over dt. dr over dt equals 10 feet per minute. We want to find the rate of the increasing area when the radius is 60 feet. Step 2. Identify an equation that relates all rates and variables. In this problem, we want to find the rate as the area is increasing. The equation for the area of a circle is area equals pi times radius squared. This relates the radius and the area that we are trying to find. Step 3. Take the derivative with respect to time using implicit differentiation. Our equation is area equals pi times radius squared. To find the derivative of this equation, we must use the power rule. First, we take out the constants, pi. Then we use the power rule and implicit differentiation to find that dA over dt equals pi times 2r times dr over dt. Step 4. Plug in and solve. Using step 3, we have come to the derivative of area equals pi times r squared. This equation is dA over dt equals pi times 2r times dr over dt. When we plug in our known rates and variables, we get dA over dt equals pi times 2 times 60 times 10 feet per minute, which is our dr over dt. So dA, when we simplify it all, dA over dt equals 1200 pi. Therefore, the rate of the increasing area is 1200 pi feet squared per minute as the radius is 60. My second practice problem. An inverted cone is 20 centimeters tall, has an opening radius of 8 centimeters, and was initially full of water. It is now being drained of water at the constant rate of 15 centimeters cubed each second. The water surface level falls as a result. At what rate is the water level falling when the water is halfway down the cone? Step 1. Read and identify rates and variables. The height of the cone h is 20 centimeters tall. It also has an opening radius of 20 centimeters. The rate as the water is draining with respect to dW over dt is negative 15 centimeters cubed per second. It is negative because the water is being drained and not added. So here I have compiled a picture for you guys. This is a cone, and inside the cone is a triangle, and here we have the dH over dt and dV over dt, which, as you can see, is equal to negative 15 centimeters cubed per second. Now, for related rates, I know sometimes it's kind of a hassle, but usually I want to draw a picture to make the problem a little easier. That's one trick you can use in order to make related rates a little simpler. Step 2. Identify an equation that relates all rates and variables. In this problem, we want to find the rate as the water level is decreasing. The equation for the volume of a cone is volume equals 1/3 pi times radius squared times height. This relates the radius, volume, and the rate of the height that we are trying to find. Step 3. Take the derivative with respect to time using implicit differentiation. If one of the variables aren't given, you have to establish a ratio or solve for that variable. In this problem, we can use similar triangles to find that 8 divided by 20 equals r divided by h. Therefore, r equals 2 times h divided by 5. If we plug this value into our equation, we get volume equals 1/3 times pi times 2 times h over 5 squared times h. We can simplify that equation to volume equals 4 divided by 75 times pi times h cubed. Taking the derivative with respect to time of both sides of your equation, we now use the chain rule to find that dv over dt equals 4 divided by 25 times pi times h squared times dh over dt. Now, step 4, plug in and solve. In step 3, we solve for the derivative of our equation, which gave us dv over dt equals 4 divided by 25 times pi times h squared times dh over dt. When we plug in our values in, we get negative 15 centimeters cubed per second equals 4 divided by 25 times pi times 10 squared times dh over dt. Simplifying this equation gives us negative 15 equals 16 pi times dh over dt. Now, remember, we are trying to solve for the rate of the height as the volume, when the volume of the water is half of the height. Therefore, dh over dt equals negative 15 divided by 16 pi centimeters per second. Thanks for watching, and I hope you learned something new.